Nowadays, it's very common for the corporations or companies to reach beyond their data center and leverage the services and infrastructure that cloud service providers such as Azure, Microsoft Azure provides to them. And there are many different reasons. Some do it probably certain time of year because they have peak seasons. For instance, the retail industry in the US, their peak season is between Thanksgiving and the New Year. And other industries may have different peak season where they need excess capacity during that period, but maybe not anytime during that year. Others, they may have reached the capacity in their own data centers, but they don't want to add more rack servers, or maybe don't have even space anymore. So they need to. It's probably easier for them and cheaper to leverage what's already there and provided by the cloud provider. Regardless of their intention, they fall under two categories. One, under hybrid clouds, and those are the type of corporations or users that they have their main services running in their own data center, but they reach to the cloud to leverage the excess infrastructure and services. So this is kind of one way they're consuming what's already there and leverage them. There are others that go beyond that, and they fall under cross-premises, and those are the type of corporations that they may set up a service up on the cloud, but they still need to leverage some of maybe the old services that they're still running on their data center. So this becomes a two-way street between their environment and from the data center and the cloud infrastructure. So they're called cross-premises. So no matter what they call those corporations or what categories they fall under, the many corporations, they have regulatory requirements that they need to meet. So security and privacy is very important to them. And we'll discuss one corporation, such corporations, and we call them Acme Corporation. This is a kind of fictitious corporations or company that we will be working with in this video. And let's say they want to set up their own Kubernetes environment. However, they don't really have the expertise to do it in their own data center, or they don't have the capacity, or both. So they want to leverage Azure and create their Kubernetes environment. So in order for them to set up AKS, so AKS stands for Azure Kubernetes Services cluster. It's very easy to just run this command, a similar command, AZ AKS create -- resource group, and specify the resource group. So we'll talk about resource group a little bit later if we don't know what they are. And then you name your the cluster or whatever you want, and the number of nodes that you want to provide. So it's very easy. Just run that, and then Azure does the rest for you. Does create the control plane and sets the worker nodes. How many you ask for, it will create it for them. So the worker nodes have private IP addresses, as you can see. However, the control plane or API server has a public IP address, which is not good. Let's say they want to now deploy an application, and then they want to create a service that sits on top of that application and run another YAML that will create, let's say it sets up a service, and the type of service is load balancer. So Kubernetes will create a service for them, and then the cluster IP, this is the internal IP address of the service. So this is, again, is private. However, when the load balancer is set up, by default, Azure gives it a public IP address because you have to reach out to that somehow. And right now, the only way to reach to that service is to have to assign it a public IP address. So we'll see now that we have a public IP address for the control plane, which is very dangerous, and it also has a public IP address for the load balancer, so the services are again exposed to the internet. So we want to change that. So we want to kind of set up a Kubernetes environment in AKS cluster where these IPs are private. However, we'll still be able to reach out and consume the Kubernetes cluster. So before going into the details, since the users of these corporations are new to Azure, and maybe some of you are as well, there are some fundamental things that you need to know, or they need to know before getting into actually setting up the private cluster. So I'll go over some of the fundamentals of Azure, how it works, things that are, obviously Azure is very, is a very vast kind of topic, but there are things that you need to know, very basic things before you can set up your own Kubernetes cluster, which is private. Let's go through those. Azure has many regions or data centers around the globe. So when you deploy a VM or AKS cluster, they're physically created in one of these regions. But Azure also has a defined logical hierarchy. At the top of this hierarchy is something known as a tenant. So a tenant is a digital representation of the corporation. For instance, Acme.com. So when Acme.com works with Microsoft to purchase licenses from them, a tenant is created for them that bears their name. So this is, again, digital representation of that corporation. Each tenant has a Microsoft Entra ID associated with it. So Microsoft Entra ID used to be called Azure AD. You may remember that by that name. So it's used to manage all the users and security within that tenant. A tenant can have one or more subscription associated with that. And for instance, in this case, Acme.com purchases two subscription A and B. Subscription A is used for developers to do their development, testing, experimentation, and then subscription B is used strictly for production. So as developers develop application, test them here, then they graduate their application from subscription A to subscription B. So subscription B is more locked down than subscription A. Each subscription can also have one or more resource groups, and a resource group is tied to a region. So anything that is, things that are related to each other, for instance, you're deploying a multi-tier application, and so those are related to each other. You have the front end, you have the business logic and database, so you want it to be logically in the same resource group. And typically, those resource groups are deployed to the same region. For instance, you can deploy a VM here, and that also deploy to the same region, but it doesn't have to be. In some situations, for instance, you have redundancy requirement that you want to deploy to multiple regions, so you define some of those resources to go to a different region. For typical application, all the objects that are within the same resource group, they should be deployed to the same region because they are in close proximity, and you get better performance than going across regions. Resource groups can be used to also manage policies, group policies, for the objects that are within that resource group. We can also set up policies at the subscription level, so that applies to all the resource groups within that subscription. You can also set up Azure Management Group policies that goes across subscriptions. So the policy, Azure policies, is beyond this video, and I will cover them hopefully in the future video. In their quest to create a private AKS Kubernetes cluster, the engineers at Acme.com will need to understand the concept of Azure virtual networks. It is actually crucial to understand that concept. So let's go over it and what it is and how we can create it. So first of all, recall that if we create a VM, for instance, in Azure, Azure will assign it a public IP address and also assign it a public DNS name. But again, this is not something that this corporation is looking for, because they're looking for privacy and they don't want to expose any of their assets in Azure with public domain names or public IP addresses. So the solution to that is to create a virtual network, or VNet for short. So VNet really is a network segmentation within Azure backend. So in order to create that, we need to assign an IP range, like a subnet, in this case 10.000/8. So that kind of creates a perimeter around this network range that we created here. And then the corporation, then they can, this Acme.com, they can create their assets within this. Or because this is a very large subnet, they can also create subnets within that subnet. For instance, create two subnets, one with the address of 10.0.1.0/24, and the other one 10.0.2.0/24. And then we can become actually creative. We can create subnets to represent their application. For instance, if they're deploying a 3-tier application, they can create a subnet for their front-end VMs, a subnet for their middle-tier VMs, and a subnet for their databases that are running in the same subnet or in the same VNet. And then they can apply policy rules. There are different methods of doing that, for instance, allow only traffic coming from to the database from the business tier and not from the front end. So that kind of thing can be done then within the VNet. And then we can create a DNS within that VNet to provide name resolution in that VNet. And finally, we can then move that virtual machine that we created earlier, we can move it inside VNet by assigning an IP address by specifying that this VM will live within this subnet, which lives within this VNet, and then assign it an IP address within this range, and also then create a DNS, a private DNS that only is resolvable within this virtual network. So this is great. So this is what kind of what we are looking for. The only problem is, how do they access this VNet from their on-prem data center? So there are a number of ways that it can be done. One is Azure Express Route, and the other method is VPN gateways, and there are two methods. One is called site-to-site, and the other one is called point-to-site. And if they just want to access their VMs, there's a third option. It's called Azure Bastion. So next we're going to go over each one of these methods. Azure Express Route provides the fastest and safest method of connecting corporations or companies' data centers to Azure virtual networks. The way it works is Microsoft has set up this edge centers all around the world, basically data centers that has routers and other networking infrastructure that connects it to its backbone, both for Office 365 and also for Azure. And those, also Microsoft has partnered with various ISPs around the world that provides direct access between their data centers and these Microsoft edges. These connections are completely private. They do not go over the internet, and they're also redundant. So there's a primary and secondary connection. And partner edges or ISPs, but by the same token, provides access to the customers, their customers, through private lines. That is, a private line will be dropped at the customer center, data center. Again, those connections are completely private. Nothing goes over the internet. There are many options and SKUs within Access Azure Express Route. However, this is more of a for the bigger corporations, and it's more expensive than other methods. For companies that can't afford Express Route, VPN gateways are also a good option because they're secure, although they operate over the internet, but they provide a secure method of communication. As mentioned earlier, client data centers cannot directly connect to a virtual network because they are really islands within Azure. So we need a method, kind of a man in the middle in order to connect these two together. And that's where VPN gateways come into play. As we mentioned, there are two types of VPN gateways. The more robust one is site-to-site because then you can connect the entire data center to a virtual network. And the communication we can set up communication that goes both ways. So in this scenario, we need to set up or create a VPN gateway on Azure. On the client, we need to also provide a device, a VPN device that has an IP address. And then between these two, a secure connection or tunnel is established. So these tunnels use IPsec/IKE method in order to provide secure connection between these two. So the IKE part provides authentication, so it ensures that these two are who they claim to be, and the IPsec provides the encryption and message integrity. And every time that you set up a VPN gateway, it actually sets up two tunnels. One is active, the other one is passive by default. So if communication between these two through this tunnel collapses, then this one automatically comes online and communication is reestablished. So this is called active-passive because at any time only one of these tunnels is active. We can make that better, more robust by assigning a second IP address to the VPN gateway and make that passive-passive. So communication then goes through both tunnels. This not only improves network traffic because now we have two tunnels that matches are going through, and also if one goes down, the other one is already up, and so there's no downtime. There will be situations where setting up a site-to-site VPN connectivity may be an overkill. Imagine the Acme Corporation has a branch office with a few employees working from there, or maybe working from home. And all they need is to be able to connect to an application that is hosted in a VNet or virtual network and do their job. In that scenario, we can easily set up a point-to-site connectivity, and the clients don't need any VPN devices like we discussed with the point-to-point VPN connectivity. And a single VPN gateway can be set up, and multiple clients can be connect through that gateway and set up their own tunnel. It happens automatically after handshake and performing the authentication, and then they can connect to the VNet. Obviously, this is only good for, again, if you have a few employees on the site that need to work remotely. However, for other times, when connectivity with your data center, when you need always connectivity, and also you may want to set up cross premises connectivity. That is, your servers in the data center be able to access Azure resources, and also Azure resources be able to connect to the resources that you set up on your data center. In those situations, definitely you need to use site-to-site connectivity. In terms of authentication, there are different methods of authentication, such as Azure Certificate and Microsoft Entra ID, depending on what operating system is being used. So there's also one more method, and that is radius authentication that I didn't bother to put up here. And that is more of a special cases where, for instance, you have a corporation that has set up their trust relationship between their Active Directory and Azure AD or Azure Entra ID. In those situations, they want to provide single sign-on, so that when the client sign into their workstation, they can automatically then connect to the gateway without having to re-authenticate. Other situations, a simpler one, they can set up either work with Azure Certificate or Microsoft Entra ID. For this demo that we will be doing, we'll be using point-to-site connectivity, and we'll be using Entra ID for authentication. In situations where you just want to connect to VMs that are hosted inside a virtual network, we can set up Azure Bastion. So Azure Bastion host basically is a secure proxy through which you can connect. It uses TLS. You can connect through that. It kind of uses kind of pass-through SSH. You can then connect to any VMs in that subnet or in that virtual network. So we can SSH into Linux VMs, or you can use RDP if you want to connect to Windows VMs. Of course, you can also do SSH into Windows VMs. So again, this is another way of connecting to a resource inside VM. But again, that's it. The only thing you can do is really you can remote desktop or SSH into a VM. And maybe this is maybe good enough for a situation that just you need quick access to a VM that is hosted inside a virtual network. During the demo, we're going to set up an Azure Bastion host to see how we can set it up. Okay, now that we got some of the fundamentals, Azure fundamentals out of the way, let's concentrate on creating our private AKS hosted cluster. And the method that we're going to use is called Azure Kubernetes Service Cluster with API Server VNet Integration. So this is a newer method of setting up private clusters. There is another way of doing that, which is involved, it's not as streamlined as this one. This is a newer method. And at the time of recording this was still in preview. But in my opinion, this is a much easier way and more streamlined and gives you a lot more flexibility than the old method. So before going ahead and actually creating the cluster, there are some things that we need to do. Obviously, first we need to create a resource group. Remember, almost anything that we create in Azure has to be inside a resource group, such as an AKS cluster. And then we also need to add a VNet, create a VNet so this VNet will be used to set up our cluster. You could leave that to Azure to create a virtual network or VNet, but that you don't really have any control over that. And suppose you have other assets, you have other applications that you want to deploy into the same VNet. Let's say they want to consume, those applications want to consume Kubernetes. So it's easier and better to actually create your own VNet and specify that as part of the process. Next, we'll be creating two subnets. We need to create two subnets. One for the API Server subnet. One is called it API Server subnet. And Azure will use this subnet to set up a load balancer. So it's a load balancer that has access to the API server. Remember, the API server will be outside the VNet. We don't really have any access to it at all. We don't even know its IP address. So that API, that load balancer that is created, it knows how to connect to the API server. So, and the other subnet Azure will be used to set up the worker node. So all the worker nodes will have the IP address in this range. We also need to create and manage identity. So manage identity is basically a service account, but these are special service accounts that are managed by Azure. We don't have to worry about the password, how to create them or how to rotate them. They are all managed by Azure. And then we need to give that managed identity, we need to give worker node access to these subnets. The access would be network contributor access. So it'll be, because Azure will be manipulating this subnet, creating a subnet, and it needs to have access to this subnet. So that managed identity will give Azure access to these subnets. And finally, then now we can run the command to create our cluster. So let's go through the command Azure AKS create -n, so it stands for name, and you can name it whatever you want. I call it private cluster 1. And -g stands for resource group. So this is basically the resource group that we created here. The name of that, we passed that. And -l, that's the location, what geolocation you're going to deploy to. In this case would be like what region you're going to deploy to. Let's say we deploy to West US 3. So that would be our location. And -- network plugin. So this is the CNI. So this is the default CNI. If you don't want to use, so Azure has its own CNI. If you don't want to use Azure CNI, you want to create something, use a different one, such as Cilium, and this is how we are going to do it in the demo. Then you specify none, and then later on you can set up whatever CNI that you want for that cluster. Then we need to specify a couple of switches, and this will make our cluster private, -- enable -private -cluster, and -- enable -API server -VNet -integration. We also need to set -- subnet ID to the cluster subnet ID. So this, again, Azure will be using this to set up our worker nodes. And also -- API server -subnet ID, and that would be the ID of this subnet. So all the objects that are created in Azure, they have their own ID. And we need to pass those IDs. And I'll show you during the demo how to get the IDs for things such as these subnets. And then we need to specify -- assign -identity, and that would be the ID of this identity that we created here. So that again, Azure will be using this to manage the cluster here. And then finally, -- server -cider is, and this is so basically this is when you create services in Kubernetes, Kubernetes creates the cluster IP. So the cluster IPs that are generated will be in this range. That, after we execute that, then Azure itself will create a resource group that it manages itself. So, and then in that, we'll create a DNS, and that DNS this is a private DNS, provides DNS lookup or name resolution inside that VNet. We'll also create the control plane, so that is the API server. Again, remember, we don't have access to this. And then it also sets up the VNet, the worker nodes. So there will be node 1 and node 2. For instance, in this case, we can specify the number of nodes that we want to also set up. And finally, it creates a load balancer. Again, this load balancer knows how to talk to the API server. So, and assigns it an IP address, which will be in this range, in this API server range. And also, it will create a name. This name will be basically, as far as we know in this VNet, this is the name of our API server. Obviously, the actual API server is different, but this is kind of a proxy that we use this to generate a configuration for our clients machine that I'll show you later. So this will be used in name of our kind of a designated name for our API server. And again, it's in fact, it's pointing to this IP address here. And finally, it creates an entry called private with the name of the cluster or clustering that we created. Azure creates an object here. Basically, we use this. You can click on that and manage the cluster a little bit. Not everything you can do through that, but kind of for cluster management. Let's say we deploy an Ubuntu server here. So this will be our jump box that we can then manage our cluster through this. And in order to this machine to connect to the Kubernetes environment, first we need to generate a configuration because it really doesn't know how to do that. So the command is Azure AKS get credential -G and the resource group that the cluster is in and the name of our cluster. So once we run that, then Azure will contact the control plane, API server, and will generate a configuration file and copy it in the home directory under -cube. You probably are familiar with .cube, so that will be the configuration file. This configuration file has this name in it, so this is how this machine knows when it wants to connect to the API server. It has to go through this load balancer, and the name that it uses will be this name that is registered here. So let's say this wants to connect to run a command on Kubernetes. Let's say kubectl get nodes. So first of all, because it has in this name, it has to find an IP address. So this DNS provides the name resolution, and that name will be resolved to 10.6.64, which is the IP address of this load balancer here. And the load balancer then forwards a request to the API server. So again, be completely in the dark of where that control plane is, what the IP address is, what the name is. These are all hidden from us. The only thing that we know about is a private name that we use to connect to it. But again, everything is just hidden, and that is the way we want it. It's completely hidden from us. So in the demo, we are going to also set up a VPN gateway. So we set up a VPN gateway, and this VPN gateway has an IP address, and that is how we'll be able to, our clients will be able to connect through VPN, client VPN to be connect to this VPN and to our virtual network. We'll also set up another gateway or another subnet, and we will install Azure Bastion host. So again, it's another way for us to be able to connect to this VM. And so this setting up this environment, setting up the client authentication is a little bit involved. If you don't want to go through that process and just want to set up to just learn it for learning purposes, and you want to just be able to connect to just Ubuntu and play with the network, then it may be easier for you to set up the Bastion host here, and do it that way. I'll provide instructions how to set up client VPN configuration and how to generate client configuration, both using Microsoft Entra ID and also Azure certificate. So it's really up to you. If you want to go through that process, you can, but if you just want to be able to quickly connect to this Ubuntu machine here and then play with the Kubernetes, is really up to you. I'll provide the instructions to do that as well. So before getting into the lab, let's discuss the requirements needed for this. First, you need an Azure subscription. If you don't have one already, you can get a free 30-day trial license if you go to azure.microsoft.com. We will be using Bicep, which is a domain-specific language for Azure. Through Bicep, we can then achieve infrastructure as a code in Azure. We will be also using Visual Studio Code, and we need some extensions to provide things such as IntelliSense in Visual Studio Code. And for authentication, as we described earlier, you have two choices if they use Entra ID as the authenticator or use certificate. So if you're using Entra ID, you need to do some prep work, that is setting up your Entra ID to work with gateway, VPN gateway, and provide authentication for it. So you need to go to this URL here and specify 3 sections, the prerequisite, then create Microsoft Entra ID users, and then authorize the Azure VPN application. If you opt out for the certificate, we will not be using the certificate for this lab, but you can set it up if you want to. And I provided sections that you need, things that you need to do. First of all, you need to, on the server side, you need to configure that and generate certificates. And then on the client side also, you need to generate some certificates for VPN authentication. So regardless of which method you'll be using, you also need a VPN client. And there are VPN client for Windows and one for Mac, and basically it does exactly the same thing. So depending if you're on Windows or Mac, then get one of those VPN so you can connect to and authenticate. So in this lab, we will be implementing what we discussed already, that is setting up a private Kubernetes cluster in Azure. And as we mentioned, we will be using Bicep. So let's discuss some of the Bicep modules or files that we'll be using for this demo. The first one is create VNet and VPN gateway. So as the name suggests, we're going to create a virtual network and a VPN gateway in this module. So we don't want to put everything in one large file, just break it up into various sections and files, so that makes it easier to manage and also troubleshoot. So the first section is defining what parameters are passed into this file, the parameters that needs to be passed in, like any other programming language, you can pass in external parameters. The first one is location, what location this will be created in. And we don't want to, we could specify equal to, for instance, US West or US Central, but the best practice is to actually get that value from the resource group that you should have created earlier. So resource group dot location would get us the location of that resource group. So that would be whatever region that resource group is created. And then we can define other things such as application name. Again, we can define application name or set the values over here, or we can define a JSON parameter file and just call it .json. I use the same name, create VNet, VPN gateway, and underscore params.json. So we can define our default values, because if you're calling this a lot, and some of those values may not change between calls. And you don't want to, if you have like maybe tens of parameters that you need to specify at runtime, it will be tedious to every time define those. So it's easier to define them in one location, the default value, and you can override them, by the way, later on if you want to. For instance, just create a gateway. So if you want to opt out of creating a gateway, we can specify no. We can specify the default value as no, but you can override that when the time that we need to generate or create that gateway. And then we define various gateways or the prefixes for various subnets. The first one is for the VNet itself. So we need to specify a large enough CIDR range or IP range that we can then carve out various subnets within that. So I'm using 10.0.008, which is huge actually. And then within that, we define as many subnets as we need, as long as we are not going over this range. So we're not going beyond that. So the first one I create is front end subnet. So in this, I'm going to, when we create the VM for the jump box for managing the Kubernetes cluster, I'm going to put that in this subnet. I've also created a back-end subnet. I'm not going to use it for anything, but it's just going to give you an idea that you can architect this subnet the way you architect your application. So you have your Kubernetes environment that you want to put it in its own subnet. Then you want to have the front-end applications to be in that subnet, in the back-end, a different subnet, maybe a database in a different subnet. And again, then you can apply security, who can talk to whom. And the next one is the gateway. So the gateway itself, we need to specify a subnet. So I'm creating defining a subnet, and this is the CIDR or the range. And the Bastion host that we're going to create later on, this would be the range or the CIDR. And then the API server, this will be the range and the cluster subnet. So these two will be managed by Kubernetes, by Azure. And then we also specify one of the goals was to create, when we create our Azure services, we want to assign them private IP addresses. So I define specific subnet for those. And lastly, we define a VPN client. So this range will be outside, or VNet has nothing to do with VNet. This is basically the range that VPN gateway, when clients connect to it, they can, and then they will be assigned an IP address during the authentication from this range. You can also define variables like any other languages, and the keyword is var. So when we define a variable, we don't have to specify a type like we did with the parameters. So we can just define a variable and then use it that way. So in this case, we are going to need to define a few variables that will be used for Entra-ID authentication with VPN. So when we create our VPN, we need to specify some of these variables. So let's go ahead and go through those. The first one is tenant ID. So that is the tenant ID associated with our subscription. So we can get that subscription.tenant ID. And then we also need to specify, so we need to, kind of when we do the claims, who we are, we need to specify, so it has a specific format. You need to specify a URL for that, and that is this one here, login.microsoftonline.com. But we don't want to hard code that, and we can get that variable or that value from environment.authentication.login endpoint, and that will gives us this URL. And the nice thing is we don't have to, in the future this changes for whatever reason, we don't have to change our application. So we can get that. That would be the active Azure AD tenant URL. That would be the tenant URL. And then next one is AAD tenant or enter ID tenant, and that would be the tenant URL plus our tenant ID. So basically, this is how we going to be to authenticate ourselves, represent ourselves would be our tenant ID plus its URL. And this would be the AAD issuer or authority. So this is the URL, stc.windows.net/ and then the tenant ID that we got it up here. And then we also need to specify something called audience, and this is basically a GUID. And depending on the situation, if you are using public Azure like this right now, so we need to specify this GUID here. If you are using Azure Government, then this would be the URL for that or the GUID for that. If you're in Germany, Azure Germany, so that would be the GUID for it. So we need that also. So all of this is really required for when the client connect to VPN gateway, and the VPN gateway is set up to authenticate using Azure AD or tenant or enter ID, the new name, then we need to specify it. So when we define the gateway later on, we need to specify this value. Let me define them up here. And then we define various other things, such as we define a resource suffix, and this is a good idea to do that. To create a unique resource suffix for the object that you create. For instance, you create VNet, and it has to be unique. And then in order to do that, one thing we can do is to get the resource ID group ID, to get the resource group ID from using this function, and then pass it into a bicep library called unique string, this function, and then get a unique string which is related to your resource group. So that would be unique to you. And then you can use this resource group, and then you can then tag it onto the object that we create. For instance, the VNet, we need to specify a virtual network name. So we specify VNet dash the application name or application called the Cosmo in this case, and then dash the resource group suffix that we defined here. So that becomes unique. The VNet will be unique to us. Then we can define other things such as front. So for the subnet that we create, we need a CIDR or a subnet range that we defined earlier in this file here. However, we also need to specify a name. So any object that you create in Azure, you need to specify a name for that. And it's a good idea to define them up front here and not in the resource itself, because then if you want to change that, it's easier to kind of manage everything at the beginning of your code. So for front end and back end and gateway, so we specify each name that corresponds to what their function. And then over here, we need to also create a public IP for the gateway, because that is how the client will be able to connect to the VPN gateway. When we create, again, a public IP, we need to specify a name for that. Not the IP, but the name for that IP that we are creating in Azure, so to identify it. So we specify PIP, which stands for public IP, and then dash gateway, so we specify the purpose of it, and then dash the application name, and again the resource name. So that becomes the name for our public IP address for the gateway. And then for the VPN gateway itself, again, we use VPN dash the app name and the resource. So again, we get to create a unique VPN gateway for gateway. Now in order to create and manage application or resources in Azure, we use the keyword resource, and you can use also IntelliSense. For instance, I want to create a DNS ID record. So all we need to do, I just type in DNS, and then it has some suggestion for me: DNS record, DNS resolver, DNS zone. So if I tab over, so it creates DNS zone and also DNS record. So it's smart enough to know that when I create a DNS record, I also need a DNS zone. So they kind of create a basic structure for creating those components. But then I can set the variables that make sense to me, or change the values from default. So this is very great way when you're starting with Bicep to use the IntelliSense database. So here we define, the first thing we need to define is, of course, the VNet virtual network. And we can find it under Microsoft.network/virtual networks, and then the version. So this is very pretty consistent all across objects that you use. When you use Bicep, you use this notation, which has a name, and the library name, and also a version, which is the date. We specify a name and a location, and also we define a prefix. So this is the VNet prefix that we defined earlier, and within that VNet, then we create various subnets, such as front end. So we again specify the name that we chose up there, and also specify the front end prefix that we define in that JSON file here. So these are pretty much the same. They're all the same, except this one and the API Server subnet, because that would be managed by Azure, and for the API Server, we need to specify a delegation. And the delegation, the service name for that delegation is Microsoft container services / manage cluster. So that will be going to be managed by that entity. And then the other ones, such as cluster subnet, and also the load balancer. So all of them, the subnets would be a child to the VNet. So that would be the kind of the parent, and these will be the children of that entity. And then, as we mentioned, we need to specify a gateway, so public IP for the gateway. So this would be the public IP. And then we specify the location, and then we specify a SKU. And then properties, we specify IPv4 or IPv6, or you can specify both. And also the allocation method, we want it to be static. We don't want it to be a dynamic, because you don't want it to change that every time that client connects to it, because otherwise they won't know who to connect to. So this would be for the public IP address. And Azure automatically will generate an IP address, a unique public IP address for the VPN. So the only thing that in our environment would be public would be the gateway, the IP address of the gateway. And if you're going to use Azure Bastion host, then the Bastion host IP address will be the only visible, publicly available IP address for the whole VNet. And then we define the VPN gateway itself. So we select a name for it. We kind of defined that already. And this is the library that you can get that, Microsoft.network/virtual networks gateway, and then the version. And then you can also, there's a nice feature of Bicep is we can conditionally create that. And the condition is equal to if, and then some condition, if some condition meets, then create this structure or this object, otherwise don't. In this case, our criteria is, do we want to create a gateway, create a gateway, yes or no? If it's yes, then it will create the gateway, otherwise it won't. And then within that, and there are various things that we need to specify, such as location, a name for it, and also a private allocation method, and dynamic. So dynamic will be assigned, and the public IP address, and that would be the ID, the public IP that we created. We need to get the ID of that gateway. So again, we get IntelliSense, we already defined that object, and we can then access its properties, and then in this case would be the ID. So this would be the identifier of that public IP. And then under subnet, we need to specify what subnet we are creating in under that. And again, VNet, again, we can get IntelliSense here. So VNet.properties.subnets, and we need to specify what the number, and that would be the subnet that we specified for the gateway. And then the gateway type would be VPN, and the type is specified route-based. So there's policy-based and route-based. So policy-based is more of a legacy. It's static routing, and this is dynamic. So we use dynamic. This is recommended. And then there's some other things that, we are using BGP, kind of a little bit beyond this course. We're not going to use BGP. And then the address prefix. So this is the VPN client IP addresses that will be assigned to them. So that would be the range that we defined earlier. When we define the VPN protocols, so that would be VPN, OpenVPN, and VPN client type would be we'll be using Entra ID or Azure AD authentication. And then finally, we need to specify some of the stuff that we defined earlier for authentication purposes. That is the tenant, the audience, and the issuer. Okay, let's go ahead and close these two and move on to the next one. So the next module that we're going to use is called Create, Manage ID, and Grant Subnet Access. So if you recall, we need to create and manage ID that Azure will be using to manage the cluster for us in that two subnets. That is the API Server subnet and the cluster subnet. So we need somehow to manage those, and that through manage ID identity that we create here, and we give it access to those subnets. So Azure will be able to manage that for us. So again, we need to specify location. Again, we're going to get that from resource group.location. And then VNet name, we need to define a few variables here, such as VNet. So we are passing in the VNet name that we created earlier. Again, we can create a JSON file for that. And then we need specify a name for our entity name. I called it Kube Network Manager-test. So again, this would be our test environment in the future. If we go to production, then we can name the production one -.prod. So when you start working with Bicep, you need to kind of look ahead and think about your test environment and production environment and name things accordingly. And the API, so again, we need to pass in the API server subnet name. So this is earlier, it was created earlier. We can define them here, or we can pass in from the, when we call the function. So it's kind of default values as we discussed earlier. And so the API server name, that needs to pass in. The cluster subnet name, we also need to pass in, because we need to give the ID that we create, we need to give them network access to this. And internal load balancer service name. So we, again, that ID, Azure will be managing the load balancer subnet through that managed identity that we'll be creating here. Next, we need to specify the role ID. So the roller, the network contributor role can be obtained calling this basically functions, script, subscription, resource ID, and then this would be the, so this is basically, you need to, it won't change. So you need to pass in, this would be basically the ID of the role, which is the network manager role, will have this ID. So this is something that we need to specify as is, like here. Then we define a resource to create the identity, the managed identity, and that would be under Microsoft.managed identity / user assigned identities, and again the version and the name. We pass in the name that we kind of decided on early on. We specify that, and then and the location. And then we need to, now that we create this, so that this step will create a managed identity. Now next we're going to get the VNet and this get a reference to the VNet and the subnets that we need to. So we need to then do this resource VNet, and then we specify again the type. If you recall, this is how we created the VNet, but here we're saying existing. So we're not going to create this VNet called, it's already there. We are just going to grab it and have access to it. And in order to do that, we just specify the VNet name. So this is a VNet that we created earlier in the previous module. We just pass it into this module, and then it finds that VNet, and then we have a reference to that. So this object node has a reference to the VNet that we created earlier. We also need to get a reference to the API Server VNet, the cluster VNet, and internal subnet library LLB, or load balancer subnet. So we need also to get a reference to those. And again, we specify the resource, we specify a name for it, and that would be the Microsoft.network / virtual network / subnets. And then we specify existing. Again, we are not creating a new one, we're just referencing those. So we pass in the name of that API server subnet that we created early on, and we specify the parent, which is VNet. So these are all created VNet, so we need to specify a parent, otherwise you can't find it. We do the same thing with cluster subnet. We get a reference to that and get assigned it to this variable, and also internal load balancer subnet. Again, we get a reference through it by defining. And then the rest of this, we will be assigning those subnets, we're giving that built-in or that managed ID access, network access to those, to be able to manage those. So we define a resource called API Server Network Contributor assignment, and then that would be Microsoft.authorization / role assignment and the version. We specify the GUID, the name, a GUID that is something new, kind of unique. Again, we need to make sure that it doesn't conflict with anything else, so we can use a different method. We use GUID, and then we pass in basically any random variable that we want. So anytime that we call this GUID and this, always gives us the same GUID value. We can, if you call the GUID without specifying anything, it always generates a new unique value. Sometimes we need that, sometimes we don't. We need to kind of create something unique for a specific value, like this one. Like I call it network contributor assignment 1 for this. And then the scope would be API server subnet. So this is the operation will be done on this. And the properties, the role definition ID is the one, the network contributor role that we define up there. And the principal ID would be the identity of the managed identity. So the managed identity that we created early on. Now we have access to it. That properties, that principal ID. We also specify the principal type. This will be service principal. And do the same thing with the cluster, the cluster and load balancer. Same thing. So basically, we are assigning. So we created here a managed identity, and we give managed identity a network access to that, so to be able to manage those. And then we can then export the principal ID. We export that to the outside world. And let's go ahead and close these two. So we need to specify a few parameters here. Again, the first one is location. And as we mentioned earlier, we can get that calling this method. And then we have a few other parameters like admin username. We need to specify an administrator when the VM is created, who the administrator name would be. And then a couple of specific operational things such as patch mode and reboot setting. We also need to pass in SSH key name. So for this VM, we are not going to use password. We are going to use SSH keys in Azure, and then we use those. It generates a public and a private key, and then we use the private key for authentication, and the public key will be downloaded into that VM in order to do the handshake. And we also need to pass in the VNet name again, because we need to access the front end subnet ID, because that's where the VM will be created. Again, we can create a JSON file and pass in some of the common things such as username that won't change, and some of the specific things such as patch mode, so it's automatic by platform, and reboot setting as if required. So those are kind of standard things that you can put into a JSON file. But we need to pass in the rest of the variable, the parameters. We then we can define a VM name. So I just chose VM-VNet name. So I know that this name is attached to that. Kind of visually, you can figure out that this VM is defined in that VNet, and also a jump box. So this is a jump. We use this VM to manage the cluster and also the VNet itself. We also need to, for that VM, we need to create a NIC card or internet access card. So we need to specify again, and anything that we create in Azure, we need to specify a name for it. So we called it NIC dash and the name of the VM. We also need to specify the front end subnet ID. We can get that, the VNet, we are passing in the VNet, and then we create the VNet object. Again, we access the VNet objects here as we did before using the existing keyword. And now this has, it's kind of a access point to get to the VNet. And then we can get that VNet.properties.subnet 0. So that would be, when we define our subnet, that was subnet 0, the first subnet. So we get the ID from that. We need the ID when we create a VM. So again, we discussed that. We pass in the VNet name here, and we get access to the VNet that we created early on. Same thing in SSH key. We need to define, create an SSH key before calling this, and we'll go through that when we go through the demo. But again, we specify existing, and then we specify a name, the name of that SSH key. So we're calling that SSH name key. We get the access to SSH key that we already created, and then we can use this later on when we create the VM. Over here, we create a network card, access card. Again, that would be under Microsoft.network/network interface, and the version. Again, we specify the name and the location, and then IP configuration. So there could be more than one configuration. So we need, for each one of those, we only use one configuration for this. We specify a name for it, and under properties, It's just going to be static or dynamic. We opting for dynamic, so every time the VM create, it automatically is assigned an IP address. And then the ID would be, so this would be attached to what subnet. So basically that this IPs will be coming from this subnet ID. So dynamically an IP which is in that subnet will be assigned to this NIC card. And then we create the VM itself. This would be under Microsoft.compute/virtual machines, and then the version number, and then we specify a name for it, and again, a location. Under properties and hardware profile, we specify VM size. So there are many sizes to choose from depending on your need. You need to look at documentation and see which one. Obviously, you pay more for more premium type. So it really depends on your situation. So you need to be careful here. So anything that you create in Azure, anything that you create, there is a cost associated. So you have to be careful of how you do that, and also be careful to delete the resources that you don't need. Otherwise, the meter is always running. Okay, we need also to specify the OS profile. Under that, we need to specify the admin user for this VM. We define it again up here. We pass in, or we define it in that JSON file, and the computer name. And under Linux configuration, we mentioned that we don't want to use password authentication. Instead, we use SSH keys. And these are the basic parameters for it. First of all, the public key, the path. So this is where the public key will be. Remember, the SSH key is stored in Azure, so it automatically download the public key, and this is where we specify to download to. So under home, and then the admin username, and then in the SSH folder, and then under the authorized key. And then the key data is coming from SSH key.properties.public key. So again, the public key will be used by the machine, and the private key will be used by the client. So the client will specify the private key when they authenticate, then the VM will use a public key that is downloaded here to ensure that this user is said he or she is claimed to be. And then the path setting that we specify up there, basically these are normal that we need to specify. Reboots. Yeah, so let's go ahead and go below here. Under storage profile, image reference, so what publisher we're using Ubuntu, so that would be a canonical publisher. The offer is Ubuntu server, and the SKU we need to specify, and you need to find whatever SKU that is using based on the version of the Ubuntu that we'll be using when you get to watch this. And the version would be, can I use the latest one? And under disk, we specify what storage type we use, because it has to create a storage type for that disk that we create on Azure. So we opt in for a standard LRS, which is good enough for this kind of POC. But you can have more premium again, like version, or pay for more for more consistency if you have to. And then under network profile, this is where we specify a network interfaces, and then we specify the NIC that we created early on. We specify the ID here, and primary is true. And then we can export a couple of values here. One is NIC.properties, the configuration, basically the IP address, the private IP address of the VM. and also the VM's ID. So again, every object that is created in Azure has an ID. We need that ID when we create the Azure Bastion host. Okay, let's go ahead and close this as well. Next one we're going to talk about is how we create a Bastion host. Again, this is optional if you don't want to use the VPN gateway. You want to make it easier, you can just create a Bastion host and just access that VM, that jump box, and access the Kubernetes cluster that way. Again, a few parameters that we need to pass in. First of all is the location. Again, we are going to get that from this. And we need to pass in the VNet name. Again, we need that again to reference that. Because again, we created a subnet specifically for the Bastion host. So we need to get to that VNet and then access that subnet. We specify a name we need to pass in a name for the Bastion host. And subnet name is a name for the subnet and also for the host. So, and this is how we create a Bastion host, and then Windows Microsoft.network.bastion host and the version number. We specify again the name, the location. The SKU is a standard. So you need to specify standard in order to make it work in for this example. If any SKU lower than this, it's not going to work because some of the parameters that will be specified later on, you won't be able to set if you don't use the anything less than standard. Under properties, the IP configuration, again, we specify a name for the config. We only have one IP configuration, so we name just config one. The properties, the subnets. So under subnet, we are going to get from resource ID, the Microsoft network, virtual network / subnets, and then VNet name and the Bastion host name. So we need to specify this subnet. And then public IP address, we specify public IP, we define it below that. We then get the ID of that IP address that we're creating a little later. So we need to specify, disable copy paste. So, this will allow us to copy and paste between the VM that we access and also from our machine. And also we need to set that to false. Disable is false, which means that enable copy and paste. And also we need to specify tunneling. So there are two ways you can access the VM through the Bastion host. One is do SSH into that. That is called tunneling. So we need to enable that. And the other method is to go to the Azure basic site, and then through that, then you can access that through the browser. But this is more convenient to use the tunneling or SSH, and that is where we need to specify the SKU as standard. And then we define an IP address as before. It's again public Microsoft.network / public addresses. Again, specify the location, the SKU, and then we, like we did for VPN gateway, we specify the IP public address version, IPv4, we're going to be using IPv4, not IPv6, and then we specify it as to be static. And output, we can then output some properties such as the Bastion name and a location and a subnet ID. So this is kind of a quick review of what we will be executing during this demo. So this script drives the whole thing. So that's why I call it driver.sh. So I'm going to set the location to Central US, environment, test. We also set the resource group as RK-AKS-private-cloud, and then added the environment, which is the test environment. The managed identity, cube, network dash, then environment, and SSH key name, I call it jump box SSH key. So let's go ahead and execute these. Now, at the time of recording this, API Server Integration was in preview. That is, creating an AKS cluster using API Server VNet Integration was in beta or preview. So you need to execute this section. You don't need to do that once it goes to production. Again, this is just if it's still in beta by the time you try to execute this code, and then you need to also execute this. Otherwise, if it's already in production, don't worry about that. You don't have to do that. Next thing, the first thing that we need to do is we need to create a resource group. So resource group really encapsulate most of the objects that we create in Azure. And the syntax is az group create -- name, and we define a name up there. Location, we also define up there. And if you don't want to see the whole JSON result, you can specify what you're looking for. In this case, I just want to show you the ID of the resource group. So let's go ahead and execute that. It should take a second or so, and it's already created. So let's go ahead and delete that. Now we're going to create the VNet and VPN gateway. So essentially, we're going to call the create VNet and VPN gateway bicep that we saw earlier. And the syntax is very close to the creating a resource group. The only difference is the AZ deployment group create, and then resource group that we created up there, we call the resource group. So, and then the template file. So this is what bicep module we're going to call, and we call it, again, that's the name of the module we talked about earlier. And then here we specify the parameters. So the first one we specify, read those parameters, those defaults that we specify in the JSON file. So those set of parameters, go ahead and read those from that file. But we want to, if you recall, the create gateway was set to no by default. So we're going to set it to yes. Again, if you don't want to create the gateway and you just want to use Azure Bastion host to just connect to that VM, just say it no. Well, let's go ahead and execute. And this will take a long time, actually. It may take half hour, sometimes even more. So just be patient with this, and we'll come back when this is completed. The deployment completed successfully. As you can see, this is basically the acknowledgement from Azure and that what deployment was done, the name of the deployment, and what objects were created, things such as VPN gateway and so on. So let's go ahead and actually view that visually in Azure. So we go back, we go to Azure website, go to our account, and then click on resource groups. And this is the name of our resource group. Click on that. And it shows us all the artifacts that generated. The first one is the public IP address of the VPN gateway. This is our VNet, or virtual network. and this one is VPN gateway. So let's click on VNet, and we can verify. If you click on subnets, we'll see all the subnets that were created, we specified in our script or in our bicep file, all the front end subnets, back end subnet, and all of that, plus the CIDR or the subnets, IP range. And also we can see that for this one, the API server subnet, we delegated that to container services, Azure container services, and that also specified here. So let's go back to our resource group, and then let's click on the VPN gateway. So connections refers to the configuration. If you set a point-to-point connection configuration, then you will see it here. Site to site. But now for this one, we opted for point to site. So this is for clients connecting to. This is not site to site, but point to site. And these are some of the parameters that we set, values. For instance, this is the CIDR, that when the client connect to that, this is the IP range that they will be receiving at IP address. The tunnel type we specified at OpenVPN, and we asked it to use authentication type Active Directory, but you could use it Azure Certificate or Radius, as we discussed it before. And there's the tenants and the audience and issuer. Those are Active Directory specific things that we need to specify, and we did. We go back to this guy here. So what we could do also, look at our deployment. So this is the deployment that we did. It says the name of our deployment and status is completed. So we click on that. We can also look at the deployment details, all the stuff that was generated. These all are created. These are the objects that were created. We can also click at inputs. So the parameters that we passed in, and these are the outputs. So these are what the bicep script exported. And actually, we're going to take advantage of this. So let's go back to Visual Studio Code. And we can now extract some of those, like VNet, cluster subnet ID, API subnet ID, and so on. So VPN gateway name, Bastion host name, host subnet ID, and Bastion host name, because we will need them to pass on to different bicep files that we're going to call a little bit later on. And the format is AZ deployment group show -G. This is a resource group. This is our resource group name. -N. This is the name of a deployment name. So by default, if we don't specify anything, it uses the name of the bicep file that we run. In this case, it was create VNet and VPN gateway.bicep. So that's it. Basically, just uses the first part and ignores the .bicep. So that's going to use as the name. And query, we say properties.outputs.vnet.value. So basically, it goes to Azure and gets the value for whatever we're requesting. And the -OTSV basically means stripped out all the JSON stuff, because the results are coming back in JSON, but because we don't need all the metadata information. Strip those out and just give me the value, for instance, for VNet name. And we do that for the rest of them. Let's go ahead and execute those. So it's going for each one of those, goes to Azure and capture those. Okay, that's completed now. Let's go ahead and clear. Now in this section, we can download the VPN client config file. Again, you can either do it through code or through Azure, the way I showed you a little bit earlier. So the first thing we need to run this AZ network, VNet gateway, VNet-gateway, VPN client, generate, then dash name, the name of VPN or VPN gateway name, and the resource group is resource group. So let's go ahead and execute that. I'm just going to run this on Azure, and Azure will generate a URL that we can use then to download that configuration file, those configuration file. That's completed. Now we're going to strip out the quotation marks. So it has a quotation mark at the beginning and at the end. And we need to get rid of those because once we do the curl and curl into that, we need to get rid of those quotation marks. And then we can echo out. And this is basically, this is the URL that we need to download. And you can see there's a .zip at the end. And then the next one, curl -o VPN client.config and config.zip. And then the name of the URL. So it's going to download the results into this file in the current directory. And that's completed now. Now you can unzip that. And it will unzip the generic and Azure generic VPN and Azure this one and the two files that are generated and generic. So we're going to use the generic VPN when we the time that we want to connect to Azure through VPN client. So we'll do that a little bit later. Next, we're going to run the script that creates an identity. So we need now to create an identity for and give a few subnets network contributor access as we saw earlier. So we're just going to go ahead and execute this part here. It takes a couple of minutes to execute. Okay, it's completed. Now we can verify the name. So we assign it to a variable. So let's go ahead and execute that. So this is basically the ID of that service account. Let me clear this. So finally, we are at the point that we can now create our private cluster. And the reason why I'm not using Bicep for this part is because at the time of recording, the Bicep for private clusters of using VNet integration was not completed yet. So I had to use AZA or Azure Client CLI in order to do that. So again, we discussed the syntax earlier in the presentation, but we go over that again quickly. AZ AKS create -n. This is the name of our cluster. I call it private cluster 1. -g, that is the resource group. And this is a resource group name. And then the location, we specify a location. We specify the network plugin as Azure -- then enable private cluster and -- enable API Server VNet Integration. So these two are the key that makes the cluster private. And then VNet -subnet -ID, we specify it to the cluster subnet ID that we created earlier. We also set the API Server subnet ID to the API Server subnet ID that we created again earlier. And then the assigned identity is this guy here we just created earlier. And then the server CIDR, this is the IP range. When the services are created, the cluster IPs will be in this range. And then finally generate SSH client. It basically means that when the when the cluster are created, for those worker nodes also generate SSH key. This is for authentication. So basically enables you to log in into or remote into those servers if need to. Let's go ahead and execute those. Again, it's going to take a little bit time, and then we'll come back when it's completed. Okay, the cluster was completed successfully. So next, what we need to do is, now we need to create a VM that we can then connect into and work with the cluster, with the newly created cluster. So the first thing that we need to do is we need to create, let me clear this. We need to create an SSH key. Like, as we mentioned, we are not going to use password in order to log into the VM that we're going to create. Instead, we're going to create an SSH key, and Azure basically will save that into Azure. So the command is az ssh key create -- and this is the name that we gave it, and this is our resource group. So let's go ahead and run that, and then that is finished. And then if you go under your home directory and SSH folder, you'll see these two. This is the pair that we just was created by running that command, and this two is the this is the private and this is the public keys that is generated when we created the cluster. So in order to log into if you need to log into a worker node, we need to use this key. That would be so the name of the user by default is Azure user, and then the password would be this. So instead of ordinary password, then you can specify the location of this file, which is under the SSH folder. Same thing for the VM. This is a private key that the VM will be downloading that when it's needed, when we are doing the authentication. And then this is our password. So the name of the user I specified was Gary, and this is the password. So this is how we're going to log into that a little bit later. Let's just go ahead and copy that, because we need that later on for logging into VM. Next, we're going to create the VM itself. So this is the part. Again, we're going to run the bicep that creates that VM that we saw earlier. Let's go ahead and let me just first clear this. And let's go ahead and run this. Again, it's going to take a few minutes, and then we'll continue once it's finished. Okay, that's completed now. And then now we can get we need the IP address of the VM we just created. Again, we're going to fetch it from Azure AZ deployment group, show -g, the same syntax we used earlier. And now we're going to get the IP address that was exported from that module. So that we got that now. We're also going to get the VM ID. So this is the ID of the VM that was generated. So that was IP address. This is the actual Azure ID. And we need this not for connecting through SSH, but once we get into Bastion, Azure Bastion, then we need the VM ID. But just save it for now. Now we can, before connecting to, let me just add the new keys here. So before SSH into that, we need to start the Azure client VPN, because we haven't done that yet. So this is the VPN client interface. So in order to connect first, you need to click the plus sign and import. And then you point it to where the XML file downloaded. We downloaded that earlier dynamically. And just point it to that, and then you need to go under the Azure VPN. That's where that folder, that XML is, under that folder. So you click on that, and then it shows you some information about the connection name and the VPN server, so on. So just say save, and then click on connect. Now it's going to challenge you with, you need to log in basically to Azure and specify your email address and log in. And also, it will, it needs to also verify. So the easiest way for the verification part is if you install Azure or Microsoft Authenticator on your phone. That would be faster. But if you don't have, or you don't want to install that on your phone, then you can also do kind of provide you other ways, such as email or some other ways that you need to verify that. So we'll verify that. We'll continue once I go through the login process. It takes a minute. I just don't want to show my email address and information. So I will continue once that's done. Okay, once you're authenticated, then you'll see that this circle turns green, which means that now you're connected to through VPN. So let's go back to our code here, and then we can now SSH into our VM that just created. So SSH -I, and then we specify the location where the private key of the SSH pair is, and then we specify the user. So let's go ahead and do that, and then say yes, we create that. Okay, now we are logged into, this is our box. This is the VM that we set up. So in this box, we need to install a few things. Let's go ahead and go through that. First of all, let me put the resource group in a variable because we need that a little later. So we're going to install the kubectl. We need to install the Azure CLI. So these are needed in order to basically work with our cluster. So let's go ahead and execute these two, and then we'll continue once that's completed. Okay, those are installed. The next thing to do is for us, we need to log into Azure. So on line 15, AZ login, let's go ahead and execute that. And it will give us a code and also like a expression and also a URL. So we need to go to that URL. You can go to any browser and log in. So once that done, and come back here, and we'll see that we are now logged into Azure. The next thing that we need to do is we need to set, if you have multiple subscription, you need to set the subscription to the one that matches the resource group that you created. So I have a couple of those, so I'm going to set that to the right one. This is the subscription that I need to set it to. And then on line 20, now we need to download, we need to ask Azure to get the Kubernetes configuration file on the client so we can connect to it. So on line 20, Azure AKS, get credentials -G, the resource group, and then the name of our cluster. So let's go ahead and do that. And we'll see that it said that it copied in the under home .cube. This is the where the configuration needs to reside. So basically, it already downloaded for us and in this location. So we should be able now to run the commands such as 22 kubectl get nodes, and we'll see that these are worker nodes, and they are in ready state. Okay, let's go ahead and clear this. Now we're going to deploy a simple hello world application on line 24. kubectl, create deployment, hello world, and we're going to get the image from this location. Let's go ahead and we'll see that it was created. Now we're just going to scale it, or so it installs only one instance. We're going to make it 3. So each one of those worker nodes will have now a copy of that pod. And then on line 28, we can verify our deployment, kubectl get deployment. And we see that all 3 are ready. Now this part, we're going to create a service for our application, and then we're going to do that dynamically. So this is very much like any other deployment that you've done, deploying services. So the API version, the kind is service. The only difference is under metadata over here under annotations. So we're going to make this internal service only. So the IP address will not be exposed to the internet. So we need to set a couple of settings here under annotations. First one is service.beta.kubernetes.io/Azure load balancer -internal, set it to true. And the other one is this one here, service.beta.kubernetes.io/Azure load balancer -internal -subnet. And then we need to specify the subnet that these load balancers will be created on. And then if you recall, we created a subnet specifically for this purpose. So let's go ahead and execute this. So it says that the service is created. So the only thing is we have to wait a little bit. So let's go ahead and run get services, and you'll see that the hello world, the external IP says is pending. So it takes a few 2-3 minutes in order to get that finished, and then we'll check in when that's completed. So let's check again if this is completed. And as you can see now, we have an IP address. So we'll see this is an internal IP address. So this is not exposed to the internet. So let's do a test on line 54. We know the port number is 8080, but we're just going to get that anyway from Kubernetes. So Kubernetes get services hello world -o JSON equal to spec, and then port number. So that would give us the port number that the service is running on for hello world. And then the IP address of the load balancer, kubectl get service, hello world -o JSON, JSON path equal to .status.loadbalancer.ingress/IP, .ip. Let's go ahead and do that. And then now that we have both the port and the load balancer IP on line 57, we're going to curl HTTP, the load balancer IP, and the port number. And we see that we get the result back as hello world. So this is, so we've kind of accomplished our mission, which is setting up the cluster IP or a cluster in Azure, and also using the internal load balancer. Since we are connected to the VPN client, then we can actually execute this service even though we are not on that VM. But because we have VPN into Azure, we can actually run the same thing. We can say curl HTTP, and then the IP address of the load balancer and 8080. And we get the same thing because we are connected to the VPN client. So next, we are going to also set up Azure Bastion host for those who don't want to go through this trouble of setting up the VPN gateway. So let's switch back to the VM. Let's actually let's exit from this, and then we'll come back to it once we have our host setup, Azure Bastion host setup. So this is the final kind of operation that we need to do, is to set up a Bastion host. So on line 104, the Bastion host, we set it to bash dash and the VNet. So we want to kind of an indication that this Bastion host is connected to this VNet. And then on line 106, we're going to actually execute that bicep file that creates a Bastion that we saw earlier. So let's go ahead and execute. And again, this is going to take a little while in order to set it up, so be patient, but we'll come back when it's completed. Okay, the deployment is completed now. Before connecting to the VM, let's go ahead and disconnect from VPN. Okay, so we see that we are not connected anymore. Let's clear this. So before the first, this is only, you have to do it only once. Before connecting to the Bastion, you need to install an extension. So this is AZ extension @-n SSH. And then we can then try now, use this command to SSH into the VM. And the command is AZ network Bastion SSL minus -- name, the name of our Bastion host, the resource group that it's in it, target resource ID. So this is the VM ID that we got it up here. And then auth type is SSH key and username. And then SSH key, again, we're going to use the same private key that we used here. So let's try, see if we can connect to that VM using Bastion host. So it's trying to connect now, and we are in. So let me clear this. So we are back again in that jump box, but this time we are using Bastion host rather than VPN client. So if we go back over here, we can try our service again. So let's get the port number and then the load balancer, and then we can then call the service, and we see that we get the same result. So this is it for this video. I hope you enjoyed it. If you want more Azure videos, just put it in the comments, and we'll see what we can do for you. Thank you.